Assalamualaikum warahmatullahi taala wabarakatuh. A very good afternoon and salam Ramadan. Okay, welcome to our third session of webinar series, Captain of Industry, brought to you by Faculty of Engineering, University Technology Malaysia. And we are so lucky today because with us today is Dr. Rezal Khairi, CEO from Nano, CEO, Chief Executive Officer from Nano Malaysia, with his topic, Bridging the Innovation Gap Between University and Industry. And without further ado, I will pass to Yang Berbagi Datuk Dekan to introduce the biography of Dr. Rezal. Over to you, Datuk.
Assalamualaikum warahmatullahi wabarakatuh, and a very good afternoon to our speaker, Dr. Rezal, and to all of you watching this webinar live through our Faculty of Engineering Facebook. First of all, I would like to say thank you so much to our presenter today. Despite his busy schedule, can still slot an hour with us to share his experience leading Nano Malaysia and be appointed as our Captain of Industry. Let me brief all of you a short biography of our speaker. Dr. Rezal Khairi Ahmad was appointed as the Chief Executive Officer in January 2013 under a secondment from Khazanah Nasional started in June 2012. He is also a board member of Nano Malaysia and Nano Commerce Sendirian Berhad, founding chairman of Nano Verify Sendirian Berhad, and founding director of Nanovation Ventures Sendirian Berhad. Currently, he serves as chairman of Advanced Materials Investment Advisory Panel Working Group under Malaysian Investment Development Authority, treasurer for Asia Nano Forum, and chairman of Commercialization Working Group under Asia Nano Forum. In September 2017, he was appointed as International Advisor to China Graphene Industry Alliance, CGIA, linking Malaysia's National Graphene Action Plan 2020 and mutual economic benefits. Formerly attached to College of Engineering, University Tenaga Nasional as an academician from 1998 to 2007, he was also an engineer at Tenaga Nasional ICT in 2003. In the year 2000, he co-founded Malaysia Events Sendirian Berhad, a startup for e-commerce platform. He holds a PhD in nanotechnology, electrical engineering from London Centre for Nanotechnology, University College London, UCL, as the first Khazanah PhD scholar from 2007 to 2010, with publications in high-impact journals. In 2014, he was instrumental in crafting out Malaysia's National Graphene Action Plan 2020 and co-authored chapters pertaining to innovation and commercialization under the 11th Malaysia Plan. His current endeavors include Internet of Nano Things and blockchain applications for high technology management. So without further ado, I call upon Dr. Rezal Khairi for his presentation. Over to you, Doctor.
Okay. Thank you so much. Waalaikumsalam to Dr. Rafiq and Dr. Iqbal earlier on my technical assistance to get things running up. And of course to Puan Moni for the MC of the day. So just to get things on board, my name is Rezal. I'm from Nano Malaysia Berhad. I'm honored to be here, to be given the opportunity to present the context and the concept of how we can bridge innovation gap between industry and academia, which is university. So before I delve and dive deeper into the subject matter, I would like to give an overview, a background about who we are. Some of you may or may not know about the existence of Nano Malaysia. We are a lead agency mandated by the government of Malaysia to commercialize nanotechnology. Understanding that we cannot work alone, and we develop an ecosystem approach. We, as a whole, we fashion ourselves, we design ourselves as a business entity to look at building the whole ecosystem based on nanotech towards the fourth industrial revolution. And as a company limited by guarantee, our parent is the Ministry of Science, Technology, Innovation, MOSTI. So our mandate here is very clear. In 2011, we were incorporatized by the government to look at the whole value chain, the whole supply chain of nanotechnology, acting as a business entity to be entrusted to focus on the commercialization and development of nanotech, We also look at how we can plan and coordinate the commercialization of R&D of nanotech, so it is aligned to industrial focus. So it's not isolated, but it is connected to the strategic focus of the country, such as electronics, food, agriculture, energy, environment, healthcare, and medicine. We're also looking at some planning and managing activities which contribute to the industry itself, which is enabled by nanotech. We also help both the private and public sector to look at strategizing and positioning of the industry in Malaysia, powered by nanotech, in the whole global supply and value chain. We also facilitate investment, both from the government and from the private sector, into the commercialization of nanotech. And last but not least, which is very important, we look at how we can create opportunities for human capital development to dabble into nanotechnology, which covers scientists, engineers, researchers, professionals, so that they can assist the company, the country, to start to have or to excite and stimulate sustainable growth for the nation. So our core business is a reflection of the mandate given to us. We look at due diligence, landscaping, consultancy. We provide advisory to the university and to the industry so that they are aligned, so they can talk together, speaking the same language, so the communication is well established. We also look at strategizing and recommending which area for the R&D to take place, because for a fact, in many decades, we tend to just shoot everywhere. We conduct R&D activities, A, B, C, and D, all the way to Z, the whole spectrum. So we look at where Malaysia has its inherent strength, our focus, leveraging our resources. So we strategize accordingly. So we don't go into red ocean, we go to blue ocean market accordingly. And having said that, we look at all those relevant business opportunities in those blue ocean markets, so that we can align the small, medium enterprises, the startups, and potential university technology transfer opportunities, so they can participate together with the sustainable economic growth. And importantly, the world revolves around money. So we also have to understand that when it comes to commercialization, it requires a lot of investment. R&D will probably exhaust maybe 10% of a product. 90% of it comes from the prototype development, the pilot production scale, the testing, certification, all the way to manufacturing. So that requires heavy investment. And we facilitate investment coming from both government and the private sector. And human capital development, we coordinate with the universities, we coordinate with the Ministry of Higher Education, and even Ministry of Education at the primary and secondary level, all the way to tertiary, to align and to stimulate interest in STEM education, but particularly with a focus on nanotech, so that we have a very strong pipeline to ensure that in the future, we have enough human capital to sustain the growth of the nanotechnology ecosystem. And last but not least, we conduct public communications activities such as conferences, webinars such as this, workshops, seminars, forums, to engage directly with our stakeholders. So sometimes we go on air, on the conventional media, and most of the time we exploit and leverage on the existing of the social media to ensure that the outreach is done very comprehensively. So objects of the company is a summary of what we do. We look at purely on economic growth and commercialization. We look at ecosystem and competitiveness. We just don't focus purely on the monetization part. We're also looking at the comprehensive approach. The whole ecosystem must be built. And the whole ecosystem must involve the universities, must involve the startups, it must involve the small, medium enterprises, it must involve the marketing platform, and most importantly, the stakeholding must also be participated by the policymakers. So it's a whole system of R and D and C. And it has to be competitive, meaning that we must make sure that Malaysia is up there so it can compete directly, shoulder to shoulder, toe to toe with the developed nation. And of course, the final objects reflecting to the previous slide, the final point, which is the public awareness. You must create market awareness. Market awareness and market creation is very critical to provide positive acceptance of nanotech. There's no point for us to develop nanotechnology, solution, product, the whole system, but without the consultation or discussion or engagement with the public, because at the end of the day, the consumers will be the one procuring or buying those nanotechnology products. It's very important for us to have this very comprehensive multiple helix approach to make sure that public awareness is done correctly. There is a developmental efforts, and we need to make sure that the promotion, the support, the mobilization of talent, technology, funding, and etc. marketing platform must be done to ensure that we deploy nanotechnology product to the market in a very responsible and comprehensive manner. And all this come together, we can re-energize industry of sort. Because in Malaysia, we have many industries that are already in existence. We breathe new life to the industry so that they can go to the next level, which I shall explain in the following slides. So introduction about who we are again, corporate information about the board of directors. I would like to introduce my chairman. He is Professor Emeritus Dato Ingenieur Dr. Muhammad Zawi bin Ismail. He is currently the chairman of Mtd Universal Holdings Berhad, former chairman of the board UKM and USM, founding vice chancellor of UNIMAS, co-founder of IMOS Berhad. And also notable mention will be Dato Sri Ingenieur Dr. Judin Abdul Karim, currently the chairman of CIDB Holdings, former CEO of CIDB Malaysia, and former DG of Public Works Department. Something which I can connect with UTM organically is one of the founding board members as well, Tan Sri Dr. Saleh bin Muhammad Noor, serving as the pro-chancellor of UTM. So there is an organic relationship with UTM from the get-go. He's a senior fellow of ASM and the first DG of FRIM. And also Professor Dr. Rujuhan bin Mustafa, currently serving as the Director of Social Services of the Ministry of Economic Affairs, now has been reconfigured as the Economic Planning Unit. He was the CEO of Education Malaysia Global Services and also the MQA. Representing our direct stakeholder, MOSTI, Dr. Muhammad Nur Azman bin Hassan, Deputy Secretary General. We have Dato Ahmad Shukri bin Haji Tajuddin, Chairman of Unimap Holdings, and Encik Muhammad Yusuf Husian, the Chairman of Tune Insurance, Malaysia Berhad. One of the reasons why we brought in Encik Muhammad Yusuf Husian to provide very strong financial background to ensure that we comply with both Company Acts and of course good governance so that our cash reporting, financial reportings are well in order. And of course myself down there. So an overview about our ecosystem, how we started up and how we're going to move forward in starting from the 11th Malaysia Plan to the 12th Malaysia Plan. A bit more further background. We received funding support from the government of Malaysia, so under the 11th Malaysia Plan. I can share with you that we received a total about 74 million ringgit for us to develop product, to look at pre-commercialization, to look at commercialization, pilot production, etc., etc. So the fund is given to NANOMALAYSIA to undertake those endeavors. So how do we go about it is we will conduct due diligence through our wholly owned subsidiary called Nano Verify. It will look at whether the nanotechnology that is being proposed to us by the university or the startup or the small medium enterprises are worthy to be commercialized. Because not all technologies can hit the market. Some technology is best to be developed as a knowledge building capacity or capacity building, and some technology will be useful for the end user or for market application, for industrial application. So our wholly owned subsidiary called Nano Verify will provide us that information about what is best for us to push to the market. So the funds that we receive from the government is used for project investment. After being given the green light from our subsidiary, which act as a consultant independently, we shall invest in a project proposed by our small and medium enterprise or startup partner and universities. So we will engage into a product development or scale-up projects. So product development in this context is, it takes idea from the university or idea from the industry to be developed and to productize. We change ideas or technology into real products which is relevant to the market. Scale-up project is when they have graduated from product development and they are worthy enough for it to be in the pilot production stage. So we have a two-tiered funding program. One is product development at a much smaller amount, about $500,000. Scale-up project is up to 1 million. This is to translate single production capacity from lab into which is acceptable by the industry. Maybe we produce from 1 to 100 units per month, so on and so forth. So we cannot work alone. we always work with the industry to understand the problem statement. So the industry will come to us, they need to solve X number of issues, they have challenges. So they will provide their information, they will provide their assets, they will provide their existing background intellectual properties for us to understand how we can help. And this is where we connect with the universities. We look at which relevant universities and research institutes in Malaysia that have compatible technical expertise relevant to the problem stated by our industrial partner. So they provide tech consultancy, R&D support, which converted into a rapid prototyping or product development project or scale-up project, which falls under our three primary program called National Graphene Action Plan, Innovation and Advanced Materials. So as a result of this partnership, we create new IPR or new intellectual property rights. And the concept here is NANOMALAYSIA funds the project, we act as an investor. The new intellectual property rights is wholly owned by NANOMALAYSIA Berhad as a holding in trust. But eventually, the IPR shall be licensed into the industry, SMEs or startup for full commercialization. This will allow the industry to translate the IPR into a new product. So the IPR is also a co-ideation work with the university. I will go into the detail how we interface and level with the university so they can participate constructively. So once the product has been developed, we consider forming joint ventures or new companies with the industrial SMEs. So this is where we take shareholding equity into the company, or we form new company together with the industry called a startup or JV. This is where we create new partnerships, we create job creation, we create employment to allow for the co-developed product based on nanotech to be diffused in the market. So once everything has been finalized through legal instrument, legal documentation, pre-agreed, everyone is happy, the product is pushed to the market via licensing or tech transfer, both domestic and international market. There's no limitation to it. And before it truly hits the market, we reconsult again with our wholly owned subsidiary called Nano Verify to certify the product. Called Nano Verified product, it offers a certification of quality assurance to every nanotech product in the market, so that when you push the product in the market, it has a nanotech claim, it becomes real, authenticated, and quality assured. Because most company, SMEs out there, they tend to leverage or exploit the word nanotech. But sometimes, or half of the time, the nanotech product does not carry any nanotechnology. So we took upon us this responsibility to ensure that before it hit the market, before consumers use it, it must be checked, it must be validated. So only buy only those nanotech product with the nanotech Nano Verify logo. So this is when we push to the market, and the return on investment goes back to NANOMALAYSIA Berhad, so we can reinvest into future project. So this is the so-called circular economy that allows us to recycle the funding given to us into project investment, working with the university, industry, forming new product, form joint ventures, push to the market, and the money that we generate from this activity shall be reinvested into the projects. So now, how do we actually get the university involved? How do we bridge the gap? It has been a long-standing or perennial issue of how we can allow or how we can get both the university on one hand and the industry to look or to land on the same page, because the language that these two entities speak can be very different. Even though we speak English or Malay or Chinese or Indians or whatever it is, the context of the linguistic communication will always be different. University has their own set of KPIs. We're looking at ranking, we're looking at building the body of knowledge, you're looking at generating human capital, training, education, exploring new ideas, publications, and lately patents are part and parcel of the KPIs, and consultancy all will contribute into how good the university is being viewed, which is understandable. Whereas the industry is all about bottom line, how they need to gain that advantage, that edge, so that they can roll out new products, so they can either capture new market or strengthen the existing market that they already are holding. So in order for us to get them to come on board, as an agency, NANOMALAYSIA Berhad, we play a role of facilitating, building that bridge. So we need to create common goals. What are the common goals that is usable for university and the industry so they can work together? So by having a common goal, common set of KPIs, key performance indicator, university and industry will begin to converse in the same bandwidth, the same language, the same terminology. So of late, we are aware that university has been pushed or pressured to be self-sustaining. So there is a commercial element to the university's existence. They're looking at how they can monetize their ideas. So there's already a push towards commercialization, technology transfer. So the KPI has already been infused into your assessment, how good the university is being perceived and perform. So there's already that component, technology transfer, patent, publications, and whatnot, and also cost consultancy. When you look at industry, they can leverage on those key KPIs, looking at product development, patenting, technology transfer, which overlaps into what they are looking at, addressing their bottom line, number one, by developing new products which is usable for the market, which will provide them an edge, which provide them to access new market territory, which allows them to expand their horizon. So by creating a common overlap, this Venn diagram, of which agency like NANOMALAYSIA Berhad, we're looking at, okay, these are our goals. Our goal is to create jobs. Our goal is to create or increase the gross national income. So by merging this commonality, creating this common denominator, university wants consultancy. Industry wants to be consulted. They want to receive information. So technology transfer through consultancy would be the best platform for university industry to start to have a channel of communication. And once this channel has been created, we zoom in on common interests. The industry in electrical electronics will look for university having the capabilities and technicalities, technical competency in electrical electronics. If they're looking at oil and gas, they will look at university having competency in oil and gas. So by creating and converging this list of KPIs, we are able to create a common KPI. When the end of the project, product development or scale up, both university and industry were able to reach their inherent or goals. Industry will have their products to commercialize. University will take in consultancy as part of their points for them to increase their perception and reputation. At the same time, if the university participate in some way, they can also co-own the technology, which can translate into potential revenue generation. So as an agency, we create this bridge, connecting the common interest between university and industry, so they see the common goal, they speak the same language. So we have options to provide universities to understand how they can participate in this endeavor. We are not rigid, we offer flexibility. So for the researchers, for university to look at, they have at least two fundamental options. So if you look at the slide here on the left-hand side, there is a called non-equity and equity contribution. If you look at the non-equity contribution, it's purely consultancy. NANOMALAYSIA Berhad, as a project manager, managing both university and industry, we provide the funding to activate projects. So we pay the universities consultancy fee. So by that virtue, the university can generate income, immediate income. But based on the principle of you cannot have the cake and eat it, this non-equity consultancy meaning that you have to give up your rights over the intellectual properties. If you feel you want to participate in the IPR ownership, you jump on board on option number 2, which is called equity contribution. But equity contribution requires the university to contribute without getting paid. So you have to contribute the time and effort and energy into the project, which can be translated into some monetary value. So when we choose a certain researchers from a university, we call it gig innovation, because we don't own, we don't salary the researchers. We pick and choose when they can contribute according to certain period of time, 3 hours a week, 4 hours a week, or weekly basis. So the research has been transplaced into a researcher's facility working with the industry. So we have this joint development and commercialization program. And as a result of this, we have the productization of the nanotechnology as a key resultant of the jointly owned IPR or wholly owned IPR. So if the university were to participate in this downstream activity, they have to give up on consultancy fee, but they are able to monetize through shareholding, through your holding company or your technology transfer outfit, and we can co-create startup or spin-off together. So the income will be long-term through shareholding, through dividends, through royalty, etc., etc. It can also work as such that if the university have an IP or patent or an R&D already completed and they're looking for partners to commercialize, it can also be the other way around. The polarity can be reversed. The university can come to us, to NANOMALAYSIA Berhad, and NANOMALAYSIA Berhad can scout and scan the industry. We can look for suitable industry partner to match with your technology. But however, an IP is not complete. You still have to undergo the joint development consent program regardless of the polarity, whereby it needs to be productized, it needs to be prototype, it needs to be scaled up to pilot production level. Then you are able to produce the finished solution that can be rolled out to the market. And this is one of the ways that we can get the universities involved in terms of bridging the innovation gap between the industry and the university to create the continuity or continuum of innovation. So this gig innovation concept, of which we mobilize the researchers to the industry, we have successfully worked with a number of universities in Malaysia. So namely, you can see UTM there. We have currently 3 projects working with UTM, 8 projects with UPM, with UTM, 1 project with University of Malaysia Pahang, UMP4, Unitem 3, University of Malaysia 2, UKM 1, Sunway University 2, UTP 3, and University of Nottingham 1. So we are being very fair, almost equally distributed, almost, 2 private universities, 2 GLC universities, 4 research universities, and 2 technical universities. So after going through the product development work, we also work with other partners such as Tech Park Malaysia, TPM, Malaysian Technology Development Corporation, MTDC, Smart University Initiative by Unitem, on their sandbox approach. So the concept of sandbox here is you get the industry to participate so they can disclose their industrial parameters, how to develop a product. The product has this certain form. It must have a certain function. It must perform at a certain level. For example, it must have a certain hardness. It must be able to process at a certain speed. It must be able to have a certain durability. So those inputs are being fed into the sandbox, and we keep on testing and testing and testing and testing in a very iterative manner. Eventually, it will be certified. Eventually, it will be uptaken by the university. And this participation of concept of sandbox, we also get the policymakers on board. We get the certification body on board. We also get the investors on board. So once everything is being met in terms of the pre-qualifying criteria, technical criteria is met, industrial parameters are met, investment criteria is met, meaning that the startup or the SME has not developed a very solid business model to commercialize the developed product. So investor will come in. Then we push it all the way to industry, such as through our startups partner or the small and medium enterprises. So some of the examples that I will share, which we have successfully worked with the university, I would like to highlight our first project. This is a good project that we have activated about 2 or 3 years ago with UTM, with Professor Azman. We work closely with Proton to develop a lightweight graphene-based materials for enhanced structural applications and improve fuel efficiency without compromising safety. So what it does is this material, advanced material based on graphene, potentially can replace metal because it can be as strong as metal, but much, much, much lighter. So it has a huge impact and application in the automotive industry. So we have something which is just as strong as metal with nanotechnology, with graphene, but it is much lighter, meaning you save on economy, fuel economy. The fuel efficiency will go up. So this is one example of which we have successfully worked with UTM. Second project will be more in the rubber industry, where we have successfully worked with a local small medium enterprise to produce and develop graphene-based tires. On the nanofluids sector, we have worked with large companies such as Komi Chemicals to infuse graphene to improve fuel efficiency and lower emission. This is one example of which Komi Chemicals already has their proprietary formula, their natural lubricant. So the next innovation comes in is the graphene, how graphene can mix into their chemical compound. That requires innovation. So we have a convergence of original technology coming from the company and new idea, new innovation, new intellectual properties developed with the university to infuse into their formulation. So the new formulation is called foreground IPR, new product with better parameters, performing much better. And the next items I would like to share will be with SCOMI Engineering. We developed a pilot project of graphene ultra-capacitor traction energy storage system. So the whole idea is when the monorail stops, it will start to quickly charge the monorail and it goes again. So we try to create a green monorail system for the market. And for the M&A research, they've also worked with multiple universities from UTM, UITM on fast charging energy storage system using ultra-capacitor. So you can start charging your battery, your whole system. Then the ultra-capacitor will charge the battery as you move along. So it is very useful for electric cars, electric scooters, and electric mobility. So next line item here I would like to share is with Pancam Technologies and QDOS Flexi Circuits, a new technology that we are introducing to the market. We're leveraging on graphene conductive ink to develop flexible circuits. So now we are able to print circuits. We are able to print sensors. We are able to print RFID devices without the use of very expensive tools. We just have to print using certain configured printers. You can start to print electronic circuits, and the electronic circuit can be flexible. This is a new wave of technology which is going to be very useful for the 400th revolution. You can start to print electronic circuit on your attire. It can sense your health condition. It can transmit signal into your mobile phone, and it can be connected to the mobile network for IoT system solution. And something closer to the ground, much more strategic to the country, we also work with a local university to develop the conversion of empty food branches from our palm oil industry into nanofiber and nanocellulose, which has a certain benefits such as a waste to wealth concept. We can create some of the various applications such as technical textiles for oil recovery, wound management, and so on and so forth. So in the same sector, food agriculture, we also work with a local company called Swiftlet Eco Park for our Internet of Nano Things solution for swiftlet farming. Some of you might be aware that Malaysia is currently the third largest producer of bird's nests. And the biggest market is, of course, China. They are the largest consumer of bird's nests. When we saw the opportunity for us to digitalize the swiftlet farming by deploying sensors into a bird's house, so we can start monitoring how many birds flies in, what will be the condition inside the bird's house. Is it hot enough? Is it cool enough? Is it humid enough? What will be the temperature? And what will be the oxygen level? Because we need to understand what is the best condition for the birds to be able to salivate to produce those bird's nests. And this information are being streamed into our mobile devices using nanosensors distributed across the bird's house. And since the bird houses are very remote, there is no Tenaga Nasional the cable or electricity coverage. So we resort to using sustainable energy solution using solar panel with battery technology. So the next item here is on LED technology. Also working with a local university, we have successfully improved the conductivity of copper. Copper has a certain conductivity. It can allow transmission of heat so that the LED does not get too hot. By infusing carbon nanotubes into copper, you improve the conductivity, meaning that the light emitting diodes or LED has no chance of getting too hot. The issue here is when the company came to see us, they say our LED gets too hot, gets so panas. How do we solve this? So we proposed the idea of using copper and carbon nanotube, taking carbon nanotube from local supplier, also from another university. I shall not name names, and the innovation of merging or creating a composite copper and carbon nanotube into a single substrate. So we're able to double the thermal conductivity, meaning it's able to remove heat very quickly. So the LED has no chance of getting too hot, and we also improve the life cycle of the LED. That's the whole idea. When you have universities to come on board to assist the SMEs, talking the same language, landing on the same platform, they collaborate to produce very, very useful innovation. Next will be working with Mtd Innovations. This is an Internet of Nano Things solution where we can actually track linen at hospitals, at hotels. So there's a lot of theft. When you go to hospitals, when you go to hotels, there's always a tendency for you to steal the wardrobe, the shower robe, the towels, the bed sheet. So by tagging or by infusing the sensors or tag device onto those linen, the hotel management is able to detect how many are there in many rooms, how many are being sent to the for laundry, how many is being used. So this will prevent theft, will prevent also prevent the hospital or the hotels from over procuring, buying something extra. So everything is accounted for. So improve efficiency, reduce cost wastages. Another highlights that we like to share is NanoSilTech's Neighborhood initiative, where we look at the production of nanosilica from rice husk. Some of you are aware that a prominent researcher from UTM is the owner of the original technology of converting rice husk to nanosilica, aerogel, and zeolite. So this is our assistance also to ensure that anything that's ideated by the university can be translated into a proper commercial vehicle so that it can properly hit the market in the best form, what kind of product. Next line item is working with a local SME. We are able to productize a technology that can allow windows to generate electricity. So imagine your windows are able to produce electricity. It acts as a solar window, as opposed to having solar panel on top of your roof. It doesn't work anymore because sometimes high-rise building do not have enough roof space to cover the whole hundreds and thousands of units. So having your windows retrofitted with the solar panel, vertically aligned, you can generate electricity sustainably. And we also identified that a certain university in Perak has a compatible technology to do so. Next line item here, I would like to share our innovation with the local SMEs is Palsa UAV Sinar Berhad on drones technology. As you can see here, nanotech covers a whole wide spectrum of innovation, from solar panel, from sweetlet farming, from rubber, from plastics. Now we arrive to a higher technology level, drones. But what is so different about our drones? Our drones is unique in the sense that you can fly 4 times longer compared to battery-operated drones, 4 times. The reason being, it uses fuel cell technology, but not any ordinary fuel cells. Our fuel cell technology is able to generate hydrogen when it flies. It doesn't require heavy hydrogen cylinder or canister. It can generate hydrogen by itself by just simply adding water. So there is a hydrogen reactor here, whereby the whole system is much, much lighter than battery. So it is able to fly longer. So a drone is able to fly longer. It can offer geoscanning. It can cover the whole palm oil plantation by a single charge. So that is the key advantage of the technology. How do you generate hydrogen on the go? We use nanotechnology, of course. Because without the nanotechnology element, the production of hydrogen will be very, very, very slow. So with the nanotechnology inclusion, the production of hydrogen is really fast, enough for it to be converted into electricity using the fuel cell technology. And next will be our work with Infusion Materials Lab, something to do more in the wellness, medical and healthcare, which is relevant to our current pandemic situation. Our material here is able to generate negative ions in the air. It can also act as an air sterilizer. So what it does is it's able to produce negative ion, charged ion, which have been proven to improve wellness, and also is able to deactivate viruses. So imagine if your indoor environment is populated, inundated by negatively charged ion, we are able to reduce the probability of viral transmission. So it becomes a protective measure, especially in the current pandemic situation, COVID-19. And the next innovation that we also work with a local university, DNA Laboratories in Berhad will be the recipient of the technology. So we have developed a nano fiber-based biosensors for detection of tuberculosis. So we are looking at repurposing this sensing platform so it can also provide ultra-sensitive, non-invasive, affordable, portable detection of SARS-CoV-2, which is the virus responsible for COVID-19, by just maybe tweaking the surface property so it can only detect that virus. Because the platform is already ready, we just have to repurpose. So we have to be aware of the current situation and quickly innovate. This terminology is called pivoting, meaning that you use the same technology but for a different application. So we have been successful thus far, but even though our result seems to be very great, it looks like outstanding, but the roads leading towards those innovations are not smooth. We have to deal with people, there are always going to be project delays, there will be communication problem, but it takes diligence and perseverance to ensure that when we have multiple stakeholders to work together, you must be able to understand how best you can manage the university and the industry, because they have different needs. And converging them to work together requires very heavy project management skills, communication skill, and good leadership to ensure that everything and everyone is aligned. So I would like to share with you with our achievement thus far. We have, since 2016 to 2019, we have developed 55 intellectual properties, filed 12 patents, 7 copyrights, 1 utility innovations. The rest are in the process of filing or better kept as a trade secret, because not all IPs are best to be patented, because once you patent out there, you're opening up your secret. There are a lot of smart people out there who can look at your patent document, they can re-engineer, alter sikit-sikit, alter a bit, and they can call it their own. So sometimes it is best for you not to patent, not to publish. Maybe this will be another session that I can share with you in future webinar on how best you can protect your IP. Not all IPs are worth to be protected. Some IP are better to be kept secret, such as the 11 herbs and spices of KFC. It was never revealed. It was never patented. It is best kept as a trade secret. Product developed, so 71 by the industry, working with the universities, and we have successfully commercialized 113 products, working with both university and industry. So the triple helix concept, agency representing the government, industry, and academia, worked. The only differentiating factor here is communication skills. You have to communicate accordingly with the industry, communicate accordingly with the university. They talk a different language, although they talk the same language. Same, but different. They can speak Malay, they can speak English, they can speak Chinese or Tamil or whatsoever, any language, but the use of it, the understanding of it, the context of it will be different, because they are aiming for different things. So pulling them together is key to the successful endeavor to ensure that both university and industry can be bridged for the innovation gap to be bridged, so that ideas from the university will go to the industry. Problems faced by industry can be assisted by the university. It's always two-way communication. So to hit what is required by us, by the government of Malaysia, we assisted at least 16 JVs and startups company. We have co-created about 1.7K direct jobs. close to 9,000 jobs, high-value jobs opportunities for the past 5 years, and we have contributed roughly about 3.5 billion ringgit into our gross national income. Indirect contribution about 17.5 billion potential, because each of these companies will create jobs. Each of the companies will sell their products. So how much they sell their products is collected under the national account called gross national income. So that's how we calculate and report back to our bosses out there. And of course, last but not least, when we push the product in the market, we must be responsible of the innovation. We must make sure that every products are verified by our certification program called Nano Verify. This is to ensure that every products have that quality assurance. It is assured to possess nanotechnology element in it. So last but not least, the segment of my presentation today is talking about 4IR, the fourth industrial revolution. So I would like to also share with everyone that nanotechnology comes close to being the prime mover of fourth industrial revolution. Because when you talk about artificial intelligence, you're talking about automation, robotics, IoT, advanced materials, sensor technology. All those can only work with nanotech. When nanotechnology comes into the picture, you have faster processing devices. You have chips that can perform or can store much higher memory. It can process much faster. And due to this advancement, you have digital devices, you have digital solutions such as artificial intelligence, IoT, automation, cybersecurity, etc. So nanotechnology is seen to be the underlying support, providing the other technological pillars as mentioned before. So also to share with you our moving forward game plan so that university can also be involved in our revolution initiative. This is our program for the 12 Malaysia plan starting next year all the way to 2025. So you are prepared. So revolution stands for Revolution 4.0, the Internet of Nano Things. So the one in blue color is IONT, which stands for Internet of Nano Things, whereas revolution comes from the word revolution to align ourselves with the fourth revolution program and looking at the number of applications. So do you understand where or which area that we are focusing on? Business services, farming, transportation, smart city, township, wearables, electronics, manufacturing, energy, hotel, cafe, hospitality. So these are the key areas that we're looking into to deploy our Internet of Nano Things solutions. Some of the existing solutions that we are offering to the market, our radio frequency-based contactless wireless charging. Yes, we can now start to charge your phone 3 meters apart. So some of you are using your Samsung or iPhone. It requires you to have direct contact for you to charge. But now we can charge 3 meters apart. And we have the onboard hydrogen fuel generation fuel cell, as explained earlier, our sensors, electric scooters, autonomous vehicle, which is very interesting technology. We are working with local startups. We have the Windows solar panel, which I've said earlier, the printable electronics, and of course our onboard hydrogen generation fuel cell drone. So this will be what is to come, what can be further developed. So we do welcome university participation to work with our industry partner. So any new ideas can take into form which is useful for the society at large. So with that, I thank you so much for your undivided digital attention. And I pass back the authority of managing session back to the MC. Thank you so much.
Thank you. Thank you so much, Dr. Rezal, Khairi, for your precious time and also good sharing with us today. Well, we believe that it would benefit to our staff, our students, and also our viewers as well. Okay, we have a few number of questions that I will share with you. All right, this is from Miss Matkia. Doctor, it would be a great if the industry could share the list of requirements, interests, and opportunities in the focus areas for collaboration with the university. We are always looking for those opportunities. And I think this is not a question. This is much like to an idea for you, Doctor. Okay. Zo, can we proceed for the next questions? Okay, you have any comment?
No, I think we appreciate, all the constructive comments so we can improve our program so it become more inclusive. If you see the program which I shared earlier on the first few slides, it reflects only three parties involvement, right? Agency, government, industry and university. So we represent the government as an agency. We have industry and university, three components. Moving forward, looking at quadruple helix. We want to get the society to be much more involved. We want to listen to what they need, because at the end of the day, the society will be the one consuming and using the product. So it will be a much more improved delivery framework. We have four components, including the society. Thank you.
Okay, thank you, Dr. Rezal. Okay, from Habibah Ghazali, I have always wanted to work with Graphene Prof. How I wish I could join this research team, but I do believe this is for Professor Azman, I guess. Okay, next question, Zul. Okay, then from Zafira Hashim, the question is, what is NANOMALAYSIA challenges during COVID-19?
Our challenges would be firstly business operation, but we managed to cope quite well converting all our business operation digitally. So we have platforms such as the webinar, we use MS Team to communicate. But what we were facing with some challenges would be our physical projects. Because if you can see, most of our projects are very physical. We have a prototype car, autonomous vehicle, we have drones. So that was put on halt, put to a stop for a bit. But we decided to be creative. We look at potential of pivoting, meaning that transferring the application of our existing technology for COVID-19. For example, that we work with two local builders to come up with or to fabricate COVID-19 screening booth. So we'll protect the frontliners, so they don't have to frequently change their gloves, masks, and gowns. So the booths are now being deployed into a number of hospitals. So we use our nanotechnology antiviral coating to provide added protection. And we also use a bit of IONT soon, so that we can we can identify the location of the booth, how many people they are screening, how many are tested positive and whatnot. And example earlier I shared with you using the TB sensors, we're looking converting it to become a diagnostic kit into a COVID-19 virus sensor. So we have creative to think how we can get opportunities presented by COVID-19, because opportunities always.
Okay, skip. Okay, thank you, Doctor.
Okay, all right.
All right. Okay, thank you so much, Doctor. Okay, the next question is from Mr. Satya Bama. Where do you get your financial support, specifically your OPEX?
Oh, okay. Well, what we do here is we are being tasked for us to be self-sustaining at some point. We have to make sure that we are able to sustain ourselves. Although we do receive funding support from the government, for us to be much more efficient, to expand aggressively, we have to also to look at generating our own income. So hence the business model which I shared earlier. When we invest in projects, we partner with university, we partner with the industry, we form joint venture, we take equity, we take shareholding, we license our technology out. So the income that we receive will be reinvested into new project, but at the same time, it can also be reinvested into covering our operational expenditure. So we are over time, we can be a bit more independent.
Okay. All right. Thank you, Dr. Rezal. Okay. I guess that's the questions for now. Okay, then I will pass. Thank you so much, Dr. Rezal, for your
My
time with
pleasure.
us. Okay. Inshallah, we will meet again with next topics. All right. I will pass to Yang Berbagai Dekan for a few words before we close our webinar. Pass over to you, Dato'.
Okay, Dr. Rezal, a very big thank you from us at the Faculty of Engineering for spending some of your precious time with us today. Lots of very interesting projects on advanced materials, very, very relevant to our staff and students. And your last few slides on 4IR flagship program, Revolution, that's awesome. So it is no longer just IoT. Yeah? It is no longer just IoT, Internet of Things, but now it is IONT.
Correct.
Internet
The
of
smaller the device,
Nanotech.
the better.
Certainly great to know that Nano Malaysia is championing IONT. We hope that we can continue working together and make more collaborations in the future. For your
Inshallah.
information, Faculty of Engineering is, I believe, the largest engineering faculty in the region. We have close to 700 academic staff, 700
Mm,
academic staff,
okay.
including computing. So we have in
Okay.
our faculty not just the engineering discipline, but we also have computing experts. And so we have a
Mm,
lot of expertise for us to collaborate. Again, thank you
yeah.
so very much, Dr. Rezal.
Yeah.
And
I would
to all of
also like to
you,
propose, Dato', if I may interject, who
sure,
knows, maybe we can do a bit of joint PhD program, because I would like to encourage my staff to develop their academic intellectual skills so that they can
excellent,
attain PhD. Maybe we can
excellent,
work towards that, right?
yes.
Yeah, yeah.
Great news
Because
indeed.
some,
Yeah,
yeah,
we have
because some of
we
what we
have
do here is new, frontier knowledge, so it can be easily converted into a PhD thesis.
yes, definitely. And by the way, we also have not just a PhD program, we also have a DEng program. So DEng program is a
Mm-hmm.
program where those in industry would like to complete a project related to their industry, related to the problems related to industry, and then has an
Yeah.
advisor from the Faculty of Engineering. Yes, definitely, more than welcome,
Yep.
Dr. Rizal.
Good.
So
We look forward to.
thank you, and to all of you watching this live telecast from the Facebook of Faculty of Engineering. Please don't forget to, now let me get this right, like, share, and comment. Yes, yes, like, share, and comment our Facebook. Thank you again very much for watching this live telecast. We have arranged many more CEOs in our Captain of Industry webinar series. Please join our next webinars, and don't forget again, like our Facebook, share our videos to your colleagues and friends. Thank you, Dr. Rezal Khairi, and thank you to all of you for watching this live telecast. Back to you, Murni.
Okay, thank you. Okay, thank you, Dato', and also thank you again to Dr. Rezal. Okay, thank you so much for our viewers. Thank you for your time, and please like, comment, and share our program. And don't forget, we have more coming webinar series next. Okay, tomorrow we're going to have webinar series with our next captain of industry, Dr. Charlene Tiagaraja, CEO TM Research and Development, with her topics TM R&D's contributions to Malaysia's economic success. Okay, at 10 a.m. tomorrow morning, 6 May, and to all Muslim viewers, selamat berbuka puasa. InsyaAllah, semoga ibadah kita diterima sepanjang Ramadan ini. Have a good day. Wabillahi taufiq wal hidayah. Wassalamualaikum warahmatullahi taala wabarakatuh. And see you in our next webinar session. Bye. Assalamualaikum.